talking about today is spaghetti bolognese. And if we have time, we might touch a little bit on software complexity as well.
But the food is the most important thing.
Absolutely. We'd like to start by establishing our credentials. What do we know about software? I'm Holly Cummins. I've been with IBM for 11 years, so very much true blue. I work quite a lot on the Web Store application server. I've also done quite a lot of work on JVM performance.
I'm Martijn, so-called diabolical developer because, as my colleagues will tell you, I get stuff wrong all of the time. So I really like this topic about software complexity because I used to, and I still do, have the tendency to make stuff way too complicated.
And as you can see from the pictures as well, we're both published authors, so everything we say must be true.
Absolutely.
Absolutely.
It's one of those rules, isn't it?
Yeah. The premise of this talk, though, was that everything we know about software we learn from spaghetti. So if we do know about software, then we must know quite a lot about spaghetti, right? Otherwise, it's just invalid. So what do we know about spaghetti?
I eat an awful lot of it, and it tastes really good.
Yeah, I think I'm in the same place. Spaghetti is nice. So is that enough? Well, what we want to do is we want to move from noodling with code to something which is a bit more solid and engineering based. If you get code wrong, it's not good. And I think this is where spaghetti is nice, spaghetti code is not nice. It's like a paradox. So, certainly in our modern software systems, you've got this tangle of dependencies. It's not just your own code which is tangled, if you're Martijn. You've got all these third-party libraries, you've got calls out to third-party APIs, you've got RESTful services, you've got resources, you've got databases, you've got JMS, and you've got 20 developers working on it as well, and you never talk to them. And it becomes a little bit complicated to work out what's going on.
Does anyone here feel they've actually got a real handle on their entire code base for one of their projects? No, it's just impossible for a single person to do it anymore, isn't it?
Absolutely. So we'd like to start just with a set of common principles, a common understanding that we build on. The first thing, one of the core pieces for managing complexity is interfaces. What interfaces allow you to do is they allow you to say, my users actually don't need to know about all of my methods. I'd like to keep some of them private. They also enable a bit of flexibility. So if you have an interface, you can swap one implementation out for another implementation. So with spaghetti, you can swap one piece of spaghetti out for another piece of spaghetti. No one's really going to be that bothered.
And another thing is, a lot of people think just because they have a single implementation that they don't really need an interface. But you should always really have two implementations, right? Because if you're testing, or if you're using test-driven development, that instantly means you need to be running against an interface.
Yeah, we're going to come back to testing quite a lot through this talk because the complexity of your code base, its maintainability, and how you test it are all really closely related. We mentioned just there that one of the things interfaces allow you to do, or one of the promises of interfaces, is that they enable reuse. They allow you to share what you've done with other people without exposing all of your horrible inner code with your to-dos and everything.
So are people familiar with the solid principles that were outlined by so-called Uncle Bob Martin, the solid principles for OO development? Yeah? Okay, so a few know about them. So the L in his solid stands for the Liskov substitution principle, which is, I think, from a lady called Barbara Liskov back in the 60s, possibly. Can't remember, I'll have to look that up again. So you kind of have two ways, especially in Java, of looking at reuse. And one is pure inheritance. And you should really look at inheritance in terms of, do I want to expose my children's public API in its entirety? So not just part of it, but all of it. Okay? Whereas composition tends to come in handy when you just want to use a part of some common functionality, kind of like the traits idea in Scala, if we've got any Scala people in the room. Yes? There's always one Scala fanboy? Yep, cool. So a lot of people overuse inheritance in Java, and they start coming up with these awful inheritance trees, and they code themselves into a corner. And that's because they tend to forget about composition. So it's good to think about the two types.
Yeah, I think sometimes you can get overexcited about inheritance and use it too much. Although interfaces are great, and we sort of started with the object orientation and the promise of the interfaces. And as we've been using object orientation for a lot of years, we've started to see, well, interfaces, it's not really high enough level. We need a concept which is like an interface, but if I've got an API, I might share 20, 30, 40, 50 interfaces. And so then if I want to explain it to Martijn, what's the entry point, what's it good for, it starts to become a bit too confusing. So what we tend to think a lot about now is this idea of services. And so it's not just at a class level, although service probably is an interface. It's a concept which is more easy to articulate, really, she says, totally failing to articulate it. As a simple example, we started off with a photograph of spaghetti bolognese, and I think you could describe spaghetti bolognese as a service. I would like dinner, I would like spaghetti bolognese, and what I photographed was Sunday night supper. And it happens that you may have thought it was a normal spaghetti bolognese from the photograph, but it was actually vegetarian spaghetti bolognese. And so this again is this idea that the internals can be concealed. You don't really need to know whether the implementation was minced beef or corn, because the service that it provides to you is a pretty nice spaghetti bolognese either way. Actually, it was sort of an average spaghetti bolognese, but we'll leave that aside.
Depends which kitchen you go to, right?
Yeah. One of the problems with both services and interfaces is something that we've been struggling with for a long time. By definition, you've got this interface. You can't instantiate an interface, obviously. It's one of the properties of an interface. And so what we started to do is we started to say, well, there's no point having my interface if in order to get hold of one, everybody has to use the impl class and do new da-da-da-da-da. Impl, let's write a factory. So we wrote a factory, but then we realized, well, our factory was actually pretty coupled to the interface, to the implementation too, and we were trying to get rid of that coupling. So what did we do?
Well, we pretty much started to roll our own frameworks. This is
wait,
what everyone started doing.
Wait, we forgot the factory.
Oh, we did forget the factories. Anyone looked at Spring source code recently? Yeah, factories. Managed factories.
Factories.
Yeah, it's not good.
No, and you realize at some point you've added 6 layers of factory, but you haven't actually got round to the original problem, which is that, you've got more classes in between, but you've still got a close coupling, which is what you were trying to avoid.
And my other favorite is the factory manager. The fact that you have to add a manager class to manage your factories is a beautiful thing. So yeah, people started rolling their own frameworks. They started trying to design service locators and all sorts of other crazy stuff. I think OSGi and a few other frameworks come up with their concept of services as well. But we do have a new popular one that seems to kind of do the trick, because it externalizes stuff. Externalizes your factory.
And that's the dependency injection pattern. The problem with all of our factory solutions is that they really get baked into the code. And so you were trying to do this abstraction, and then when you look at your code, you realize that actually you've got 30 lines in every class, which is just trying to get hold of the things that you're trying to use in a decoupled, independent way. And it's actually made it worse than it would have been if you just used the impl.
Does anyone actually have impl classes in their code base? Ooh.
We had a typo when we were writing these, and I thought I fixed it, but I think there's been a save problem. So you can see the
externalized factory problem.
Yeah, you can see the Freudian typo. What that's supposed to say is externalizes the factory problem, rather than externalized factory problem. But dependency injection, it's been a bit trendy for a while, and I think sometimes, when these things are trendy, you look at it and you say, yeah, it's a bit of a fashion. I don't need that in my code, do I? Because I've got my home-rolled factory framework.
That's right.
But it really is incredibly powerful, and it has a lot of benefits. It's not just that it gives you a framework. One of the things that is really good about it is it moves all of the management of your services from your code to somewhere else. And so if you change your mind and you decide that the dependency injection framework you're using is terrible, you don't have to completely rewrite everything. You just have to change one place.
And so there's a bit of a tip with Java these days. There is actually a dependency injection standard. It was JSR 330, I think, back in the day. And you'll find that Spring, Juice, and Pico container all actually implement that standard. And as long as you don't use too many of the crazy features that these frameworks can throw at you, you can actually swap between your dependency injection containers quite easily. Juice and Pico container, for example, are very, very lightweight, and Spring is a little bit heavier, shall we say. But it has lots of other useful things for enterprise developers.
One of the other real strengths of dependency injection comes when you're trying to test your code. So at runtime, you may want to run with your full, rather heavyweight dependency injection container. But at test time, at least for some of your testing, you can completely ignore your dependency injection container, and you can just write a test that stubs in everything. And it allows you to much more effectively isolate bits of your code to test them, because the connection between your code is externalized, so you can just come in with your scissors and go snip.
Example of that we use recently is we were talking to an external third-party web service, a RESTful web service. And during our test runs, there were no way we could actually get hold of that service. We couldn't get hold of it reliably. Right? Because we were actually using dependency injection to inject that service, we were just able to, at test time, inject our own version of the service, which was just a straight callback, which just randomized some data back to us. So it behaved like a service, but it was nice and local to us.
So what can you do? What lessons of wisdom can you take from our first 10 minutes?
Well, be really, really ridiculously strict about dependency management. Who here does look after their dependency management? Yeah, so not everybody. So your dependencies will get away from you really, really, really quickly. Okay, they're like small children, or they're like otters running around. If you don't corral them in quickly, they'll get away from you and they will cause major, major damage.
The first step in managing them really is to understand them. So we'll talk about tools a bit later on, but certainly there are tools that you can use at build time to keep a handle on them. There's stuff like JDepend. There's also, of course, OSGi, which allows you to keep a really strong handle on it.
It seems to be quite popular at the moment for people to be hand-drawing diagrams all over the place, and I actually think this is fantastic. So do think about drawing out your dependencies just on the whiteboard with your colleagues, or on a tablet if you're really cool and hip and you've got an iPad or something similar. There are some tools out there which will attempt to draw these things out for you automagically, but a lot of them tend to be fairly darn buggy, or they go way too deep and you get a diagram that starts from the bottom of the floor all the way up to the top of the ceiling. So a nice simple hand-drawing diagram will save you.
And when you look at your diagram at the end as well, there's some things that you can look out for. So if your diagram looks a bit like a fork, then things are probably pretty good. If it looks like a circle, things are less good. If it looks like spaghetti, you need to do some work.
And if anyone's ever looked at the class interaction of Java itself, it's not even spaghetti, it's spaghetti mixed with spider webs. It's very interesting.
Tasty.
Yeah.
So if you do take on board everything we've just said, you've got fantastic dependencies, you've drawn them all out, you've managed them really strictly, you think, I am golden, I am going to write the perfect product, nothing can stop me. And this is where it all breaks down.
This is where it all breaks down. We have been stuck in jar hell for a very, very long time now. And the analogy is kind of that you've got all these beautiful interfaces, you've got your dependency injection, you know which bits of code you're reusing, and then you wrap it up in a big ball of mud and just throw it across the wall at someone. And all of a sudden, that big ball of mud hides all the beautiful modularization that you've got on the inside. So jars are like big balls of mud. They're really, really ugly ways to try and share code and data.
So what's the problem with a jar? I mean, it looks pretty good, right? Well, the problem with jars is that they're transparent. And I know this is a spectacular insight, and I can also tell you that grass is green and the sky is blue. It's amazing. I think this is a little bit more interesting than that as a statement, because jars are transparent in two ways. First of all, they are physically transparent, as you can see, but they're also transparent in the Java sense. They allow you to see everything inside. And this is really, it's a bit sad. So Java, in its design, it's got really strong modularity in some ways. So, we've got this class level modularity and they encapsulate the data. You can't see the inside. We've got packages that then encapsulate classes, and packages, again, can conceal some of the internals of the package. And then jars contain packages, and so you think, oh, great, so I've still got my encapsulation, right? The jar can conceal some of its contents. But no. There's no jar scoped access modifier, so as soon as you put something in a jar, everyone can see it, everyone can instantiate it, everyone can then code against it, and then everyone can then file bugs against you when you change something in the jar that you didn't intend everyone to see, and they've all been using it.
Which is very upsetting. Yeah, there is no jar scoped access modifier, which is really sad. It just is a zip archive at the end of the day. So like any other ordinary zip archive, you can just go in and do with it what you will. There's no security in place, none of that good stuff.
But it gets even worse than that as well, because if I give you a jar, what do you do with it? What does it mean to you? Well, it actually means very little to you. Again, I may as well have just given you a zip, because there's no way to look at that jar and say, if I want to run this jar successfully, what else do I need on my class path? And there's two ways that you can find this out. One is to go read the documentation and hope that the documentation is correct, which, well, obviously it will be, of course.
Not if I'm writing it. Very bad at writing documentation.
And the other way you can do it is you can do it by trial and error. So you start your jar, you run it, it runs great. You think, oh, great, I've solved my class path. And then I give it to Martijn.
And I run it on my machine, and I get a class not found exception.
And if we're lucky, that happens quickly. If we're unlucky, that happens 3 months down the line in production, when a really obscure path got used and we never knew it needed that. And
it's not good.
It's
and
very
I
sad.
do have a horror story here. A £300,000 trade was lost in an unnamed bank that I was working at because it went down one particular exception path, which was using a particular logging framework at runtime, which wasn't part of the class path. Bye-bye trade. Needless to say, the business were not terribly impressed. And it was such a simple dependency bug. And that was simply because people had no idea that this dependency even needed to be there.
Another problem with jars is they've got no versioning. And again, when we started writing jars, this was fine, because we wrote our software and we were so pleased that we wrote our software and released it, and that was fine. 10 years down the line, we've got all these legacy systems. Which version of the logging framework do I use? Which version of the logging framework have I been tested with? No idea. And again, you could use the wrong version. You could test it in your sandbox. It works great. And then you deploy it, and you realize you needed this method that was only in the slightly later version. And it becomes incredibly hard to manage these kinds of things.
And we do a little bit with versioning these days. I mean, you can certainly put a version number in the name of the jar file, but I can go in and I can come along and rename that, right? So that's not really all that meaningful. People can put things in the manifest. That could help.
Yeah, if you're running on Windows, you might have class path length issues, and you might take out the versions from the names of your jars in order to keep it all. After all, it's just...
I'd forgotten about that. That's a good one, yeah. You can't have file names of a certain length. Just chop that version number off. Brilliant. Yeah, so there's nothing inherent in a jar which enforces versioning. So it's incredibly dangerous. So we have these pretty awkward tools to try and enforce this.
And a final problem with jars has to do with how you look for classes. So if I've got my class path, and I've got 600 million classes on my class path, and I'd like to find one of them, I have to look and look and look and look. Is it in this jar? Is it in this jar? Is it in this jar? What about that jar? If you're on a fast machine, you sometimes don't notice that. If you're on a slow machine, it can get quite painful. And of course, it's extra sad when you spend all of that time looking, and then at the end, what you get is, no, I couldn't find that, I'm going to crash your application. And you think, if only there was a way for the jars to declare what they had in them and what they needed. And this is just, you know, I have to tell you now that actually the rest of the talk is just problems with jars. We've got problems with jars 1, problem with jars 2, problem with jars 3.
4, 5.
We talked earlier about the services and the interfaces, and how really, you know, you wanted to have your interface, and then you didn't want people to just instantiate the implementation. You wanted them to use a factory, and unfortunately then you had to have a factory and a factory and a dependency injection framework, and then a framework to manage your dependency injection framework. And, you know, particularly if you're just getting started, this can be a bit challenging. And if I just give you a jar, you may look at dependency injection, and you may look at your jar and you say, but all I need to do is instantiate the implementation. So the jar doesn't prevent you from doing that. And it actually encourages you to do that, because it's easier to just use the implementation than it is to use the interface.
And we see a number of times where people are so used to having this all access 24/7 bar being open for them, that if they struggle to find the implementation they want to instantiate, they just go to the next best tool, right? Reflection, yes. And that just causes even more horrendous problems. So not only do jars encourage bad behavior to begin with, but then the secondary default behavior is equally as bad, if not worse. And we have class loading problems as well. This is a pretty famous diagram that I think Yevgeny from Zero Turnaround puts up every year in his Why Do Class Loaders Suck talk. And the problem is we have a whole bunch of class loaders loading jars and loading classes in a hierarchy. But we're allowed to have them all point to each other. So here you can see we've got our bootstrap class loader. It's loading something like a logging framework. And our application, we've decided we'll extend that logging framework and we'll create a custom level, and it's all hunky-dory, right? Can you see the fact there's actually a big circle in this diagram now? Yeah? So the garbage collector can never actually go and collect these objects. And we have the beginnings of a nasty memory leak. So the way that jars and class loading currently works is another major problem for modularity, because it also causes memory leaks and performance problems. So more horrid stuff.
Take home message again, forks are good, circles are bad. So what can you do to fix this problem?
Think modules. And unfortunately in today's world, we don't have very many solutions for this. We have OSGi, we have JBoss modules, if you've looked into that, and fingers crossed one day we might get this thing called Jigsaw, but we don't really know yet.
So we're going to talk a bit about how you convert your jars into modules, how you think about modules. And we're going to try and keep it mostly free of, you know, specific tooling, specific frameworks.
But Holly does work for IBM, so you know you have to put in a tool or a framework in somewhere. Otherwise the code is not filled, right?
So when we start with it, you know, you look at your existing code base and you say, I need modularity. So you start by thinking, well, what other code does my code touch? If your code looks like this, it's pretty tricky. You know, if I look at this piece here, I can see it touches quite a lot of that red mass. It touches the green mass. There's some orange under here that I think it might touch, but I can't quite tell. Even if I just want to sort of fish this one piece out to look at it in more detail, it's going to take a long time, and I'm going to get pretty sticky fingers. And the reason we care about what code the other code touches, you know, it's not just an academic exercise so that I can draw a pretty diagram. I need to know that if I change this, is it going to ripple through the whole system causing chaos? Or can I make a fairly neat change quite safely?
So where does it connect? Right. A lot of people just think that, you know, if it compiles, ship it, or if it compiles, we're fine, we'll just run it. Mike at the front there is going, yes, that's his philosophy as well. But we actually have connections at all sorts of different times. We have connections at compile time. We have connections at runtime.
That would be the reflection again, among other things.
The reflection amongst other things. We have, curiously in Java, especially for those of you who follow test-driven development and things, We have dependencies that we only care about during our testing, so our testing frameworks or our mocking frameworks or potentially even a different logging framework you might use. And then you have the evil one, which is what we call the transitive dependencies. And this is where you didn't realize that that little innocent-looking tiny library that you depend on depends on 15 others itself. And those 15 depend on another 20, and so on and so forth. And it gets even worse. Because in that massive spider web or that spaghetti mix of dependencies, they might be depending on different versions of the same library. It gets very, very nasty very fast.
And so you sort of go through this logic flow if you're using Maven, because first of all, you're using Maven and it's great. And then you're using Maven and it's downloaded the internet. And then you're using Maven and it's crashed.
Yes, sadly, sadly so.
So how can we modularize things? When we start thinking about modularity, I think we think, what do I need to do? I have this big mass of spaghetti. I just need to make it into neat modules, right?
You just get a knife and fork and you just cut your code into 4 even pieces and you're done.
Yeah, absolutely. I mean, this is brilliant, right? Like I've got huge clear bits of white space between my code. I've got 4 jars.
Brilliant.
Ship it.
And we're done.
Well, not quite. Just because you have divided up the code does not mean you have good modularity. They are not necessarily insufficient. And particularly if you have an existing code base, to retrofit modularity onto it, it's very hard. It is a non-trivial problem.
Does everyone here work on legacy code? Yay! Lucky us, right? Actually working with legacy code is really, really fun. So instead of seeing it as a chore, no, I'm quite serious here. And I don't know if Sandro's in the room. Sandro here? No. Find a guy here called Sandro. He's a very excited Brazilian. And he loves working with legacy code because of the really cool challenges that you run across, right? And Michael Feathers has written a fantastic book on how you can actually apply the knife and fork like a scalpel in your legacy code to start pruning bits and pieces out, you know, testing to ensure that you still have your correctness while starting to add proper modularity. So it's a great resource to start from.
What you're aiming for is something like this. And particularly if you think about modularity from the start, it's a lot easier to get that. And then once you have that, you know, it becomes so easy. So you think, well, if I change one of my pieces of green spaghetti, what else does it impact? Well, I probably need to test it with the other pieces of green spaghetti, but the red spaghetti is pretty isolated from it. And what you're aiming for is you're aiming for clear modules. And I haven't really got that on this diagram, but then you're aiming for quite well-defined joints between your modules. And you want these joints to be flexible as well. So you want to be able to say, if I take out this whole pile, substitute a pile of blue spaghetti, which I didn't do because I didn't have blue food coloring, that's all okay. And what you don't want is joints that are a bit like steel rods. You know, so it's not enough to say, well, I've got these two and they're separated out. But if I take out this, I have to take out this because otherwise everything collapses. You know, then again, it's not quite right modularity.
I was going to ask you how you got the green spaghetti, actually. Is food coloring?
Food coloring, yeah.
Awesome. Okay, cool. Must try that at home.
Yeah, when I sort of said, yes, I've got to go work on my talk, I'm off to make pasta. It was an interesting conversation. One of the things you need to do too, or one of the things that really helps keep that division between, you know, your little piles, is to enforce it with the class loaders, because otherwise you start off with this, and then a year later you've got that, and it's a bit sad.
So if you remember back to the diagram where we're showing the 4 class loaders, so you bootstrap your extension libraries, generally speaking your application or your web server has got its own class loader, and then your application comes on top of that. It's not easy to do in the enterprise space in particular, but if you look carefully at most of the web or app servers, they actually have some pretty well-defined semantics and configuration files that tend to extend either WebXML or something along those lines that allow you to say, I want my application to run in its own class loader. And then I want to have that inherit from the application server's class loader. So it avoids the problem of, let's say, JBoss giving you a version of Spring and you using your own version of Spring and having the two clash with each other. So if you isolate the class loaders, then you'll avoid that problem.
Yeah, OSGi does a lot of work with class loaders to keep the code isolated, but even if you're not using OSGi, you definitely probably are seeing this. So as you said, if you've got an ear running in a server, you can't see the internals of another ear because
it's been isolated from you.
Yeah, because if it's a bank,
otherwise
it's in theory.
Yeah.
Otherwise, you start to get problems. Where that breaks down, of course, is with this, I've got everything 100% isolated. It's absolutely fantastic until the green spaghetti needs to use some of the red spaghetti. And then I've got no way of bridging across that class loader boundary. And so what you want actually is you want something a bit more like a colander. You want to have a lot of your code isolated, but then you do want to have, again, these joints, the very controlled access between your modules. I told people, that I was doing a talk with Martijn and that one of the things I was going to be talking about was OSGi. And a few people said, you're going to get Martijn to talk about OSGi. And so just to make it...
I'm not an OSGi fan.
completely clear. Obviously, I've written a book on OSGi. I am sold on OSGi. Have I mentioned OSGi, 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 OSGi? This is the 5-year-old section of the talk.
We had to make some concessions when we wrote this together. This was one of the concessions.
Yeah. I think sort of carrying on with these really strained food analogies, OSGi is a bit like an onion. So it has been known to make grown men cry. And if you're doing something simple like a sandwich, you wouldn't want to use an onion because an onion sandwich would be disgusting. If you're making something more complicated, like a spaghetti bolognese or a lasagna, if you make it without onion, then you'd find actually that's not really nice. I wish I had used onions.
So I guess my only warning about OSGi or any modularity type framework is that it doesn't stop you from designing really bad modules. And you only have to look at, does everyone here use Eclipse? Right? So Eclipse has actually got this fantastic OSGi solution under the hood, right? But because the plugin authors write their modules really, really badly, when you do things as simple as, I want to upgrade my Eclipse, it says, no, you have this really weird dependency error 100v, blah, 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 blah. And people say, oh, OSGi is broken because it didn't fix that. Actually, no, it's the author of the module who got it wrong, and no framework can save you from that.
No, OSGi enforces your design decisions, and that can be really valuable. But it does not stop you from making idiotic design decisions. And if you make idiotic design decisions, OSGi enforces the idiotic design decisions, which, again, may not be what you wanted. And again, I think with OSGi, this is a bit what I was saying before, it's a question of scale. So if you're working on a really simple project, you're looking and think, no, I don't need OSGi. And in fact, I don't even need modularity at all. I don't need to think about that. Because look, I can completely see what code the green spaghetti touches. It's just those two other pieces. I've got no problem. But the complexity, it really does grow with the size of your project. And at some point then, your project has grown and you've decided that I need some sort of modularization. One of the things that's really important is to choose the right granularity. So if your module is too small, then it's not really actually a module, it's called a class. It's not buying you that much. Everything you need is somewhere else. You can't fit much into your pot. Just to do a basic task, you've got to bring in 6 other dependencies. If your granularity is too large, you actually have a similar problem because it's doing too much. There's too much in the pan. And so again, you've got all these dependencies. Because it's doing so many things, it's got loads of dependencies.
Yeah, and you should use I guess, Uncle Bob's quite right with this as well. So he talks about the single responsibility principle in terms of designing your classes and methods. You should think about that with your modules as well. A single module should do one thing and one thing well. So like you can have God classes, you can also have God modules, and that's just as bad.
So it's a bit like Goldilocks and the 3 bears. Some are too small, some are too big. What you want is just right. And the technical terminology for this is that you want modules which are highly cohesive, so everything in them is focused on the one task, and loosely coupled, so that there's not a whole tangle of dependencies to the other modules.
we've got here what is seen as a fairly common approach these days, especially if you're using something like the Maven module system, build system. So a common approach is to absolutely clearly isolate in your module what is your external interface to somebody on the outside. Okay? So typically you're starting to see a lot of people now throwing that into a foo API package. And that package typically contains no implementations whatsoever. It's just interfaces. Right? So that keeps it really, really clear in your minds and really clear in your modularity story. You'll often have things like a foo core, a foo UI, perhaps a foo data store. So anything that you would logically group off. So any third-party thing that you are dependent on, each of those should be represented by an individual module. So if you're dependent on a database, you have a module for that. If you're dependent on third-party service A, you have a module for that. Third-party service B, module for that. And if you follow that basic principle, generally speaking, you get just about the right granularity.
Another advantage is if you do separate your API from your implementation, even if you're not using OSGi, you do get a bit of enforcement, because if you only put the API on the compile time class path, it ensures that people don't drill down and use your implementation. And if you do want to swap out your implementation for another one, that is, in principle, possible.
And the bottom point is still so important. If you spend 3 hours arguing with your colleagues about the name of a class or a name of a module, that is fantastic. Argue for 2 days if you have to, right? Because if you don't get the naming right, you don't actually understand what is inside your module or inside your class. And things go horribly, horribly wrong. And the impl name, generally speaking, is not the greatest naming scheme in the world. Just to poke fun at people.
One thing about modularity certainly is that it isn't free. You do have to think about it, and you don't want to get overexcited and add interfaces to every single class in your, because then actually you've made things worse for yourself. You've increased the complexity of your system rather than reducing it. And sometimes, we do see problems as well where we've come up with what we thought was a good modularization. And then a while down the road, we discovered it wasn't flexible enough. And someone is using the interface, and they say, there's no method for this, and that's the method I really need. I know on the implementation class that method exists. So what I'm going to do is I'm just going to cast to the implementation class and then use the method, and I've got no problem. Well, actually, you do have a problem. And if you're seeing this pattern a lot, it indicates that your modularization isn't right.
And like in Holly's household, this problem then expands to other people, because poor old Paul ends up doing the dishes.
So what can you do?
Well, there is a bunch of tooling out there at the moment. I'm not saying it's brilliant, but people commonly...
With the exception of OSGi, of course.
With the exception of OSGi, of course. Should have gotten sponsored to do this talk. A lot of people use Maven. A lot of people scream about Maven, but at least Maven makes an attempt at resolving your dependencies for you. A lot of people who hate the fact that Maven kind of forces you down a particular path that it and its owners want you to go, quite often drop to using Ivy, which mixes really well with Ant or with another tool called Gradle. So if you're looking for build time tools, then these can really help. And as we mentioned before, you have OSGi, which is probably the de facto module solution out there today. The JBoss folks have also thrown their hats into the ring. But nothing beats drawing, and drawing is fun.
So now that you've got your modules, how do you manage the relationships between them? It works great for the first release, but then, again, things might start to break down. What you really, really don't want and what you do risk is mix and match hell. And again, versioning, it's a bit like a best before date on a food. What it tells you is that under certain circumstances, this cheese is going to be fantastic for you. If you eat it on December 20th, it's maybe not going to be so good for you. If you eat it in 2015, we won't be held responsible for the consequences.
You end up being very ill.
Yeah, very, very ill indeed. So how do you do your versioning? Well, there's some fairly well-established conventions.
Yeah.
If you have a major increment, for example, if you move from 1.0 to 2.0, you're saying, I break consumers. If you're using 1.0, 2.0 is not going to be a happy experience. You get class def not found exceptions, method not existing exceptions.
Mm-hmm.
If you've got a minor increment, for example, 1.0 to 1.1, it's a bit less drastic. So if you've provided an implementation of this API, there's going to be a problem for you because perhaps a method got added, you haven't implemented that method, bad things will happen. If you're just using the interface, things are probably fine. With a micro increment, what you're saying is, I promise I didn't break anything. And I think this one can sometimes be the most challenging one because something like an internal improvement, a performance fix, that's fairly safe for a consumer.
Speaking of broken, I think our English there is impeccable on that last sentence. Scala is absolutely famous for this, right? This is why Scala. People who try and use Scala in the enterprise right now, quite often scream blue murder because a tiny point release will come out and their entire code base is broken and horribly broken. So this does actually have really serious impacts. Other versioning schemes like using the date doesn't work. Using your own name, which is what I used to do, Martijn, Verburg, copy, that doesn't work either. So yeah, try to stick to these rules that most sensible people use.
There is a problem with these rules, though, which is that when I explain them, they sound so sensible, don't they? Of course, I want to be able to articulate what's changed. And then I've been working on my product for a year, and then I do my release, and it's 1.0, and then I work away for another year, and I think, wow, I've doubled the effort in this product. I've got like 6 times more features. It is so much better. I need to call it 2.0 because it's so much better. And then if someone sensible comes along and they say, no, you need to call it 1.1 because you haven't actually broken everybody using 1.0. And then I get really sad because I say, but I worked so hard on it. I need to increment my version by something quite big, right?
Or you have a good marketing department.
Yeah, and they say, how are we going to sell it if it's only 1.1? No one's going to buy 1.1. And so you do get this tension between the marketing version and the semantic version. The scheme we described on the previous page, it's called semantic versioning. You can look up a white paper. And it just doesn't always get adopted as widely as we hope.
Yeah, and Java itself is a good example when we all of a sudden jumped to, I think it was Java 5 from Java 1.4, and now we have this kind of weird double naming scheme where the internal versioning number is 1.70 or 1.80, but on the outside, the marketing folks started calling it 5, 6, 7, etc. The other point to make about Java is people who complain about the fact that backwards compatibility has to be maintained at all costs. And this is one of the reasons why. Right? Major features were implemented early on, and you just can't get rid of them anymore, right? Because you end up breaking, as Brian and other people will have said, 9 to 10 million developers and hundreds of millions of users. So you get yourself into your own trap very easily.
So what can you do? Use these semantic versions. Don't get sucked down the marketing trap. If you do have users, which we hope you do, backwards compatibility is important. They will thank you for it. Absolutely.
And a way to get around this is by the use of plugin systems. It does give you a lot more flexibility to get around this. So you'll see that's becoming now very popular. If people here use Jenkins or Hudson at all, yeah, for the continuous integration, yeah. So you'll see that Jenkins Hudson has got a plugin system to manage this problem of dealing with all the different small versions that they need to release to keep moving quickly. Okay, so it means that your customers can choose a different plugin they need to work with your core system. Quite helpful.
So finally, let's talk about testing. Usually when I give a talk, I have a section on testing, and it's always at the end. And I always say, I'm going to leave lots of time for testing, because it is the most important thing. And then it ends up not having very much time at all. So you can see that giving a talk is actually exactly like software development. In this case, though, we said testing, and what we actually meant was tasting, of course, to carry on with the food analogy. So what does our pasta taste like? You'd never dream of cooking something and then not having a taste, but I think sometimes we do. you know, we say, oh yes, I've developed this, and yeah, it's fine, right? Because I know what I'm doing.
I cooked it.
I cooked it,
Yeah,
exactly.
Of course it's going to be fine.
And one of the challenges with testing and tasting is that testing simple things is easy. If you're trying to test a complex thing, it gets a bit harder. The good news, though, is that there is an easy solution to this. Make your things simple. Problem solved. So how do you do this? Well, it's all about unit testing. Again, you know, carrying on with the cooking analogy, if you were making spaghetti bolognese, you'd taste the spaghetti. Is it cooked? Is it, you know, is it poisoned? You taste the bolognese sauce, you know, is it okay? And you break your system down into components. And again, just to say about dependency injection, this is where it becomes really useful. So if your pasta needs a sauce, you don't want to do it with, you know, your proper main sauce. You want to say, well, okay, what does it taste like with water on top of it? Straining
Soggy
the metaphor, soggy, yes, and maybe that's
spaghetti,
not the
not
best
so good.
analogy. No, but yes, unit testing, good. But unit testing, of course, is not enough. You do need integration testing. How does the system work together? And I think, again, this is one of those things that we think is a good idea in principle, and then sometimes we forget. And in this case, what I have here is I have hummus on pasta. Hummus is nice, pasta is nice. Hummus and pasta, disgusting.
Try it at home. It's an interesting combination.
Yeah, and sometimes these mismatches can be unexpected. So I think probably I could have guessed that hummus and pasta would be horrible. But what I have there is I have bolognese sauce on the front, and I have salsa as the second one. And you can see they look pretty similar, right? They're both kind of red and mushy. Salsa on pasta, horrible. And you know, you'd have to try it to know that. You do get these combinatorial problems, though, with integration testing. So I can test hummus and pasta, that's fine. But if I also have salsa, carrots, bolognese sauce, and I want to try all of those on my pasta, it starts to get expensive. And then I've got red pasta, green pasta, blue pasta. I've got a lot of combinations. How do you manage it?
Well, one of the things you want to look at is, I guess, your A/B testing, as it were. So out of the 100% of code that you write, usually only about 2% of it is actually ever excised, right? And the same goes for your interfaces and your interactions with those interfaces. So with your integration testing, you don't need to test the entire matrix. You just need to test the paths that your users use most commonly, right? Those are the important ones. If you have a rare path, which is really expensive, like the £300,000 trade, then yes, you need to add that to your testing matrix. But generally speaking, you just want the popular ones.
So what lessons can you take away? Test early, test often, test again. Test at lots of granularities. Do your unit testing, do your integration testing, do your system testing. Once you decide that that's much too much like hard work, let a machine do the testing for you, because you have better things to do.
Is everybody here using continuous integration of some sort? Yeah? If you are not, do yourselves a massive, massive favor. Grab Hudson or Jenkins or TeamCity or any of these free CI servers. Just try it out at home or try it out on your desktop. It takes you all of 25 minutes to do, and it will change your life. And if you want to be all hipster and go to the cloud, there is a service called CloudBees, which does this for you. Magic.
So we were going to talk about tools, but we have 1 minute left. So I think we'll just whip through them. We've already talked about continuous integration. Continuous integration makes everything good, is the short version.
Yeah.
OSGi makes most things good. It gives you explicit dependency management. It controls your class loading for you. It enforces these boundaries. It gives you version management as well, so you can say, I work with this version, but please don't give me that version because it won't work. It also gives you an absolutely lovely service framework. So instead of doing your factories, it gives you a service registry which you can take advantage of. And you then have declarative services and dependency injection on top of that. So you've got Blueprint, you've got declarative services, so that you don't have hard couplings to OSGi in your code, because hard couplings are bad. one of the nice things about OSGi as well, particularly if you're not using a hard coupling to the service layer, is you can, if you write an OSGi bundle, you'll find it's actually just a jar file. So it will work great without OSGi, it will work great with OSGi. So it gives you that flexibility. If you want the enforcement, you can have it. If you don't want the enforcement, you haven't lost anything, and you've thought a lot about your modularity.
Yeah, so I was really against OSGi for a long time because it just seemed so heavyweight and so enterprisey, and it seemed to be really popular in the enterprise space. But once I was actually forced to sit down with, I think it was Neil Bartlett, and I wrote, well, we'll see in the next slide, won't we, a few lines of a simple manifest file, and you're done. So it's not onerous, it's not difficult, and it's quite a good thing to put in right from the start regardless, because you can still deploy to an OSGi environment or not, and it'll just run perfectly either way.
Yeah, a manifest, it's a bit like a recipe. So, you say, what I'm going to give you at the end of this is I'm going to give you a lovely cake and a nice icing, but what I need for this to be successful is I need eggs, flour, and sugar, and if one of those is missing, it's not going to be a good cake, so let's not even start cooking. So that's it. That's the end. And we are aware that we're speaking last thing before lunch, and that lunch is probably pasta, and that you've been looking at pictures of pasta for the last 50 minutes.
Subliminal messaging, folks.
Yeah. Hungry, hungry, hungry.
Yeah.
So thank you very much.